Okay, same chapter, measurement technique. And the topic is compound error. So in compound error, we have to calculate uncertainties during mathematical calculations, during mathematical operations. And the simple mathematic operations are, number one, addition. Number two, subtraction. Number three is the multiplication. Number four is the division. And number five is the index or the power. So these are the simple mathematical operations: addition, subtraction, multiplication, division, power means square, under root, cube, like this, okay? Now, these types of errors, compound errors, are divided into groups. So this is the division of the group. So this is group 1 and this is group 2. So the group 1 is about addition and the subtraction, and the group 2 is about multiplication, division, and the power. Now the group 1, G1, in addition and subtraction, reading part of the measurement. Reading is treated according to mathematics requirement. Mean, if we have to add, then we add. If we have to subtract, then subtract. So readings are treated, or reading is treated according to the math requirement, but uncertainties are added in both operations. Mean, whether it's addition, whether it's subtraction, we have to add uncertainties, we have to add error, because during addition and subtraction, during this type of the calculation, errors are not reduced, they are added, they will increase. So they are added. For example, measurement number 1 is 5.6 plus minus 0.1 centimeter. And the measurement number 2 is suppose 3.1 plus minus 0.1 centimeter. Then when the question is calculate M1 plus M2 with uncertainty, so we will add the readings. This is 8.7 plus minus, readings are also added, 0.2, answer in the same unit. Next, if it is M1 minus M2, then the readings are subtracted. So 6 minus 1, 5, 5 minus 3, 2, but the errors are added, not subtracted. And if the question is calculate M2 minus M1, then the answer will be minus 2.5 plus minus 0.2 centimeter. Okay, before moving to group 2, we have to learn about the significant figures. So the rule number 1, left side zeros are not significant figures. 1, 2, 3, 4, 5, 6, 7, 8, 9, all are significant figure, but the problem is with the 0. So if the zeros are at the left side of the figure, so they are not considered significant figure. For example, 0.79, 0.081. So this is not significant, not significant, not significant, this significant, this significant, this. So this is written in two significant figure. This is also written in two significant figure. And the next pose 0.789, not significant, 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 significant. So this is three significant figure. Now move to the rule number 2. Any sandwich zero or the zeros are considered significant figure. If the 0 is coming between the two number, then it is significant figure. For example, 801, significant, significant, significant. So this is 3SF. Similarly, 70009, significant, 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 1, 2, 3, 4, 5, significant figure. So any sandwich 0 between the two number is a significant. And number 3 rule is right side 0 without decimal place is considered not significant figure. For example, 760, significant, significant, not significant, then it is too significant. Yes, it can be written as in three significant figure, but in this condition, it has only two significant figures. Suppose 81000, again two significant figure. So these are not significant, these are significant. Right side zeros without decimal in the figure, not significant figure. And the number 4, right side 0 or zeros with decimal place in the value in the figure is significant figure. For example, it is 8.10. So due to this decimal, this is significant, significant, significant. This is 3 significant. 9.600. So this is 4 significant figures. Now, the number 5, if the figure is 5,000, so in this shape, it is just one significant figure. It can be written as 5 into 10 power 3. It is one significant figure. It can be written as 5.0 into 10 power 3. So now it's two significant figure. It can be written as 5.00 into 10 power 3. So now it is three significant figure. It can be written as 0.5 into 10 power 4. So this is one significant figure. So it can be written as 5.000. Now it is a 4 significant figure. So in this shape, one significant figure, same value, one significant figure, this value, two significant figure, this value, three significant figure, this value, one significant, this one into 10 power 4, sorry, 10 power 3, this four significant figure. So 100, 500, 300, 5,000, 10,000 can be written as according to the required significant figure. But in this situation, right side zeros are not significant because there is no decimal, so it will be considered one significant figure. Now move to the group number 2, which is about multiplication, division, and index power. For example, there is a formula, F is equal to M V square over R. So M multiplied by V power 2 divided by R. So look, three operations together. Multiplication is there, division is there, and the index power is there. So in this, reading final is calculated from the formula. For uncertainties, either add fractional uncertainty or percentage uncertainties. So errors are not added, uncertainties are not added, their fractional errors or the percentage errors are added. So for this group number 2, where we have to deal with multiplication, division, and the power, reading is calculated from the formula, but for the uncertainty, we will use either fractional uncertainty addition or percentage uncertainty addition. For example, F is equal to mv square over r, this formula given, and with m as 5.0 plus minus 0.1 kilogram. The speed is 20.0 plus minus suppose 0.2 meter per second, and the radius is 2.0 plus minus suppose 0.1 meter. So this is the reading for the mass, reading for the speed, reading for the radius. So first we will calculate the reading of the force. Formula mv square over r is equal to m is 5 v20 square divided by radius 2. Okay, so after calculation, this is coming 1000. So this is the reading, this answer for this. But now we have to calculate the uncertainty in F. So we will write the formula F is equal to this M V into V divided by R. So we will write the fractional errors. So first the fractional error of the M, error in M over reading of M, plus error in V over reading of V, plus again error in V over reading of V, plus error of R over R. Whether it's multiplied, it's divided, we have to add fractional error. So the sum of all four will be the fractional error of the force. So very, very important. If the value is multiplied, divided, its fractional uncertainty is added. Now on simplification, it can be written as delta F, delta M over M. This becomes double, so 2 times delta V over V plus delta R over R and times this F over here. So when the value is power 2, then we will multiply it by 2. If it is v cube, we will multiply it by 3. If it is under root, then we will multiply it 1 by 2. So the power shortcut is the power is multiplied during fractional uncertainties calculation. So now put the values. Delta f, it will be plus minus, yes, uncertainty plus minus, delta m over m. So delta m is 0.1 and its mass is 5. 2 times delta v, 0.2, and divided by 20 plus delta r over r. It is 0.1 divided by, I think, 2, and multiply by f is calculated 1000. So now calculate this fraction. Okay, so these are the values. So 0.1 over 5, 0.4 divided by 20, 0.1 divided by 2 into 1000. This first value is 0.02, this again 0.02, this is 0.09 into 1000, 0.09 into 1000. So finally this error in F is 90 Newton. Now we have to write the final answer with uncertainty. So F is equal to 1000 is the reading, plus minus 90 is the error. But we have to justify the significant figure. We will look at the reading. So this is 2 significant, this is 3 significant, this is 2 significant. So if the significant figures in the reading are different, then we have to write answer in minimum available or minimum used. So minimum used are 2. So we will write this 1000 into 2 significant figure. So can I write it 1.0 into 10 power 3 plus minus? We have to write this error according to the significant figure of the error. So this is 1, this is 1, this is 1. So we have to write it in significant figure 1. So this is already 1. So this is the answer, but for the brevity of the question, we can write it 1.0 into 10 power 3 plus minus. It can be written as 0.09 into 10 power 3. So which can be written as finally 1.0 plus minus 0.09 and whole times 10 power 3 Newton. This is the force. This is the force which is calculated from the formula F is equal to mv square over r. Look at this. Formula given, mass, velocity, speed, or radius given, force is calculated the formula, then fractional uncertainties are added, and finally, this is the answer, but we have to write in justified significant figure. Reading significance are minimum 2, so we have to write in 2 significant figure, or error in 1 significant figure. So this is correct answer, this is correct, but this is the most correct answer. Okay, now percentage method. So the force is calculated again from the formula mv square r, and the answer will be same 1000 Newton. But we will use percentage uncertainty to calculate the uncertainty in F. So F can be written as mv over r again. So the percentage uncertainty in force is equal to percentage uncertainty in mass plus percentage uncertainty in speed plus uncertainty in speed again plus percentage uncertainty in the radius. whether it's multiplied or divided, we have to add the fractional error. We have to add the percentage uncertainty. So in short, it can be written as delta M plus 2 times percentage of V plus percentage of R. So this is not required in the exam. This is the requirement, okay? And this is also not required, just for the explanation. So we calculate the percentage uncertainty of the mass, move to this value. So here, percentage uncertainty is uncertainty over reading into 100, percentage uncertainty over reading into 100, percentage uncertainty over reading into 100. So 5 ones are 5 twos are 20 times 0.1, it's 2. This is 25 so it's I think 1. And this is again 2. So this is 2%. This is 1%. And this is again 2%. 0.1 divided by 2. Sorry, this is 5. This is 20 and this is 2. So this is 50. So 50 times this is 5. And this is 25, so this is 1. 5, 20, this is 2. Okay, so the mass percentage is 2. This speed is 2 times percentage of V. V is 1, so 2 times 1, and this R 5. So it becomes total 9%. Now this is the percentage uncertainty. So what is the delta F then? It is 9% of F, which is 1000. So 9% means 9 divided by 100 into 1000. 2 zeros cancel. Look again, it's coming 90 Newton. So it doesn't make any difference whether it's calculated by the fractional uncertainty or the percentage uncertainty.